Mike Pennacchi here, getting ready for our webcast. So we've got just a few minutes before the top of the hour. So we will, a couple things. I just want to make sure that you can see and hear me okay. And that is one of the things that I always like to do when I start these webcasts out. There's a chat window right there in the Zoom panel. If you wouldn't mind sending me a chat message saying, Mike, I can hear you and I can see you. You know what? It's always worked, but I always like to make sure that it is working. And here's the other thing that does. This is a live webinar. It is 5 a.m. here in Seattle, and I want to make sure that you know how to use that chat window. And the reason I want to make sure you know how to use that chat window is because I want you to ask questions. One of the things that is a benefit of doing live webcasts like this is that you can ask questions as we're going along. Now, what I'm going to do is I've got a fair number of things to go through, but once we get through those, I'm going to be answering questions. We'll be taking a look at things. We've got equipment set up here. So this is a live webcast. It's a live demonstration of this. So we're going to go through just a few slides. There's things that I always want to make sure that we have go right. And we're going to do those in the slides. And then we will give some of the hands-on stuff a try. So, hey, got people coming in from Belgium. Got my buddy Tim there from Atlanta. So it's always nice to see people that that I know show up on these. All right. So we'll give it a couple more minutes. Just the numbers are climbing up here as far as people joining onto the webcast. And we're going to be talking about, the Etherscope NXG from NetAlly here. We've got an Etherscope sitting right there, all hooked up. Got our 10 gig connection going back there to the back room where we have the ProfitTap Booster and the Iota. So I've got those wired in. I've got some pictures. We'll show you how those are hooked up back there. But we're going to be using those as a way to go in and grab some packets. Okay. So that is fantastic. All excited about this. All right. It is the top of the hour, and I don't want to spend too much time not talking about how to get the right packets. So we're going to go ahead and get rolling with our presentation. Let me just make sure we got folks on. Everything's all set up. I'm going to pop that Q&A window up too, just because oftentimes folks like to use that one as well. So let's see. All right. So we're going to go ahead and get rolling with our webcast today. I'd like to welcome you. My name's Mike Pennacchi. I'm owner of Network Protocol Specialist LLC here in Seattle, Washington. And I, as part of my business, have the opportunity to work with some phenomenal companies out there. And two of those phenomenal companies are NetAlly and ProfitTap. And what I like about these companies is they make tools that help me get to the root of critical network problems. The other thing about the tools that these two companies make is, as a guy that grew up building things with Legos, it's nice to have a purpose-built tool that does something, but it's also nice to have a collection of tools that can be put together in unique configurations that will solve a specific problem. And so part of what we're going to be taking a look at today is how we can go in and combine these tools from NetAlly and ProfitTap into a solution where we can go in and capture the right packets the first time. And so that's really the focus of our presentation here. So, well, I'm going to go in and do some live capturing and things like that. I do want to kind of set the tone of this, go through a couple of the products before we get in and actually start capturing packets. So I'm going to go ahead and share my desktop here. And we're going to run through a few of these. Again, if you've just joined on, please ask questions. I'm going to be keeping an eye on that chat window and that Q&A window. And when we get to the end of this little presentation, which isn't going to take very long, I'm going to start addressing questions, and we'll start doing some of that live hands-on that I know you love. So our agenda here for the presentation today, quick introduction, who am I, why am I even in here talking about these tools? The tools we're going to be talking about, we're going to talk about doing packet capture with the NetAlly EtherScope NXG. And I've been very excited about this. In fact, I'm in the middle of developing the course material for the first boot camp that we're going to be doing soon on this tool. Then the ProfitTap Booster. And we're going to see the ProfitTap Booster is one of those tools that if I had the time to build something like that, I would have built something like that. In fact, I've got a Raspberry Pi sitting here on the bench. I've got all kinds of things. In fact, what we're going to find out is that tools like the Iota have come out of ideas where we've combined different tools together and said, hey, why couldn't we put these in one? And what do you know? We've got it. We are going to talk about the Iota, another very cool tool. And we're going to look at how we can put all this together. So we've got tools from two different companies here. We're going to look at how we can use those in conjunction with each other to get to the root of network troubleshooting, okay? So one of the questions that came up, is this webinar also useful for AirCheck G2 users? We can touch on Wi-Fi with the Etherscope NXG, and a lot of what we see with what we can do with some of that, not one for one. In fact, you probably see I've got a AirCheck G2 on the bench back there behind me. What we'll find is today we're going to really focus on wired packet capture, but at the end of this session, we'll move over into wireless capture. We'll take a look and see what we can do with that Etherscope NXG when it comes to wireless capture. And the great thing is we can do many of those same capture things, a little different interface with that AirCheck G2. So my name, Mike Pennacchi, owner of Network Protocol Specialist. Here at it, I've been troubleshooting networks professionally for the last 25 years. Started capturing my first packets back in 1995, and I got hooked. And as part of that, I've been in pursuit of those perfect packets, right? Trying to get those packets that are going to help us get to the root of the problem as quickly as possible. Now, the goal is, how do we validate, troubleshoot, engineer our networks so that we don't have those problems in the first place? But we will always end up having some sort of problem, some application slowdown where we need to go in and we need to get the right packets. And so that is really what we're focusing on today, is how can we go in and find those devices, get an idea of what their addresses are, get the packet capture set up properly, get all of the packets, and then be able to come in and analyze those. I started out as a LAN administrator, and that's where I started capturing packets. I had problems I needed to get to the root of, and so to get to the root of those problems, I had to get in there and capture that. You've probably gotten a reminder email from me, so you have my email address. It's mike@nps-llc.com. If you ever run into any issues where you're trying to troubleshoot a problem, you need a little help, hey, give me a call. We'll set up one of these Zoom meetings, and I can always look over your shoulder and help you troubleshoot that. All right, so what's this about? Well, the focus of this webcast is, without the right packets, analysis is useless. I have spent years getting trace files from people where they capture in the wrong place, they capture on the wrong device, they capture at the wrong time. They're not the right packets. So it doesn't matter how good I am with a tool like Wireshark at getting in and analyzing and seeing what's inside those packets if I cannot get the right packets in the first place. So this is something I've taught for years. We need to be able to get in the path of the packets. We have to be able to get in that path of the packets. We can't just plug into a switch port. A switch port's going to give us broadcast, it's going to give us multicast, it's going to give us packets to and from the analyzer, but it's not going to give us the packets that we necessarily need. So in order to go in and troubleshoot these problems effectively, we need to get in the path of those packets. And that's where we're going to see the tools like the Booster and the Iota come in. These are tools specifically designed for getting in the path of the packets. I need to be able to capture full line rate. And I'm going to show you some screenshots. One of the things that I was told about the Etherscope NXG is that it could capture at full line rate 10 gigabits per second. Great, I'd love to be able to do that, but can I? So in preparing for this webcast, one of the things that I did is I connected an analyzer to the Etherscope using my little direct access, my DAC cable right here. And that's one of the things that I like is, these tools that I've been working with support these coax DAC cables. So instead of having to use optics, I can use copper, and just makes it a little more rugged and nice when I'm plugging into a switch or something like that. But what I did was I set it up to transmit traffic at full line rate 10 gig, captured the packets, and I'll show you, we captured every one of them. So I trust but verify. I wanted to make sure that if I was told that it could capture at full line rate, that it could actually do it. Turns out it can. Filter on MAC address, IP addresses, be able to filter down. We're going to see that whether we're using the Etherscope NXG or the IOTA, we're able to start going in and picking out those conversations that we're most interested in so that we can capture on that traffic. Easily get the packets from the captured device to the analysis machine. We're going to see, and I don't specifically call it out as a tool, I really should, and in this presentation, we're going to look at Link Live. Now, Link Live is the cloud-based software that allows me to tie the information I've collected on my Etherscope NXG up to the cloud and then bring that back down to my PC. So the beauty of this is that if I have this Etherscope out at a remote site, I can go in and I can have somebody do a capture out there, upload it to Link Live, then I can download it onto my PC and analyze it. I need to be able to resolve the MAC addresses and IP addresses to names. And this is where we're going to see that the discovery capabilities of the Etherscope NXG allow us to go out and discover the devices on the network, their names, their addresses, and where they're connected. So what I did was I did a little Excel magic on the download from there and created an Ethers file and created a host file for Wireshark. What we're going to see toward the end of this when we start taking a look at packets is I'm no longer looking at MAC addresses and IP addresses. I'm looking at names at a data link layer and at a network layer. So this gives me an opportunity to go in and figure out exactly what's going on and who's doing it, because I've spent enough years going in and going, oh, okay, dot 121 is this and dot 185 is this. That is a waste of time. It is a waste of time trying to remember IP addresses and what device it is when we can go in, we can run a discovery, and we can find out who's out there and what they can do. So that is the essence of what we're going to be talking about today. So here are the tools. We've got our NetAlly EtherScope NXG. This is a Android-based handheld tool. In fact, we've got it right there. There it is. We will go in and take a look at that. In fact, I can even do nifty things because it's Android. I've got a little Bluetooth keyboard attached to it. So it makes it really easy for me to go in and connect to that. We've got the ProfitTap Booster, and we'll dig into each one of these, but this has 4 inline taps that allow me to go in and tap into 4 different connections and then aggregate that into a 1 gig or 10 gig connection, depending on what sort of optics or if I plug my DAC cable in there. And then we've got the IOTA. So let's go ahead and talk about each one of these tools in just a little more detail here. And that is, we've got our Etherscope NXG. One of the keys with this is it is portable. So this is a handheld battery-powered device. It's Android-based. And what we find is that this has a whole selection of of apps that have been vetted by NetAlly, where I can go out and load those on there. So not only can I use this to do my packet capture, my discovery, and all those things, but you'll notice it's got a little web browser. It's got Chrome right there. We are going to use the Etherscope NXG to access the IOTA. So if I go into a facility, I can put the IOTA in, put that in line and get that capturing, use my Etherscope NXG to remote into that IOTA, get things started, get things configured up, and then I can go out and use this to do my network discovery and find all the devices on the network and use the full line rate 10 gig packet capture capabilities on here to tactically go in and capture specific packets I'm interested in. It's got wired and Wi-Fi interfaces. So this has 802.11ac 4x4 card in there, so it can go out, can communicate as far as on the wireless side. We can test wired and Wi-Fi interfaces. It's got wired and Wi-Fi management interfaces on it. In fact, when we come over here and we flip over, I've got a cable connected up right here, and I've got a cable connected up right there. So I'm able to communicate with this out of band through that Ethernet interface on the side. We're going to see that we've got our packet capture, we've got our network discovery, we've got our layer 2 path analysis out here, and this is really a neat one because it's using SNMP to query the routers and switches so that we can figure out where things are located. So let's say that you don't get inline taps and you don't get all that. Even if we're just using this, what we can do is we can go in and we can use this to find out where devices are connected. So if you are setting up span, I'm going to talk about span in just a little bit and why it's so much better that we use an inline tap. But if we are using span, we need to know where that device is connected. And you can go through and you can start tugging on cables and tracking things down, or we can use something like this. It's going to go out, discover how we're connected up, and we know exactly what switch and port that device is connected to. Now, this will capture full line rate 10 gig, but we only have a 1 gigabyte capture buffer. Now, I'll tell you, when it comes down to it, I'd really rather not look at a gig of traffic. So we're going to find that we use this for going in and capturing very specific packets in very specific places. And that it will do that either via the wired interface on the top, where we can go up to 10 gig, or via the Wi-Fi interface. So great, easy tool for going in and doing a wireless packet capture. In fact, I was just out at a site recently where I couldn't get connected to my little wireless access point I carry with me. And we did a capture and we found out that they were de-authing me. They were going out and knocking me off the network when I tried to connect to my own wireless access point. So by being able to do the packet capture on the Etherscope NXG, we could see exactly what was going on. Now up on the top of that Etherscope NXG, we have a couple of interfaces. We've got our LAN port. Now the neat thing with this LAN port on the copper side is it will do 10, 100, 1000, 2.5, 5, and 10 gig copper. And we can plug in, or we could plug in an SFP right here, a 1 gig or 10 gig SFP, and it treats these as a single port that's capable of doing up to 10 gig. So we've got a USB port, antenna port, all kinds of things that we will talk about in other webinars. This one we're going to focus on our packet capture. And so we can, our little SFP link is shown on the copper port. We can even do PoE validation with this. But in this case, we've got a 10 gig SFP plugged in, SFP plus plugged into that port, and we're going to use that for doing our packet capture. So I mentioned before, I believe that it can do 10 gig packet capture, but if I'm going to tell you that it can do 10 gig packet capture, I needed to prove it to myself and give you something to look at. So I took a different analyzer I have that's capable of transmitting traffic at full line rate, 10 gigabits per second, and I used that to transmit traffic to this. 64 byte frames, so as many frames as I could. It was 14 million some odd packets per second that I sent to this analyzer. And what we see is we're capturing packets with an interframe gap of about 80 nanoseconds, and we captured 100% of the 10 million that I sent. Now it says displayed. I had to filter down. We had 3 extra little packets in there from the discovery, but we were able to capture all 10 million frames that we sent at 10 gigabits per second. So I feel very confident in saying that I can do 10 gig packet capture with this. Okay. Network discovery. So this is another big part. We're going to come back and take a look at how this works and how we can upload that and download the CSV file. But what the Etherscope NXG will do is it will discover through the wired management, wireless management, Wi-Fi port, and wired port. So all 4 ports it can use for discovery. It'll discover wired and wireless devices. It breaks the layer 2 ceiling. It will scan the wireless network, use those MAC addresses and AP associations that it discovers, and combine that with what it discovered on the wired side. So now we can get information such as names, IP addresses about Wi-Fi devices without ever having to associate or authenticate to the wireless network. So this gives us a way we can go in and start doing that discovery to see what's out there. we use SNMP to map devices to switches and ports. So I've got my discovery here. We can now take that discovery information, upload it to the Link Live cloud, download that as a CSV. I chopped it up, reformatted a couple of things, and now I have my name files for Wireshark. So when we take those packets that we captured at full line rate, we bring those into Wireshark, I have names instead of just IP addresses. And I see there's a few questions coming in. I'm going to run through this, and then I'm going to go through and dig through those. So if I don't answer your question right away, it's not that I'm ignoring you. It's just I want to make sure I get through this. I want to be very respectful of your time. Here's the ProfitTap Booster. Now, the Booster is a really neat little thing. This is what I love when I'm talking to the ProfitTap folks is I go, man, it'd be really cool if there was something that did this. Oh, well, would you please just look at our entire product line? We have that. We built that. We saw a need for that. And building these, I hate to say little tools, but some of these smaller tools like this that do some incredible things. So what this does is this comes in and these are 4 inline taps. They support 10, 100, and gig. So I can plug into these and they will pass PoE. I was pleasantly surprised when I ran one of the tests that I plugged in a VoIP phone, boom, phone came right up. So what this does is it takes those 8 connections and it aggregates that into this one port right here. Now, one of the issues that we always have with aggregation taps is packet loss and reordering of packets. Because if I tap into a full line rate, full duplex link, and I have 1 gig going in each direction, and I aggregate that into a single gig connection, it's not all going to fit. I'm taking 2 gig of data and jamming it into a 1 gig port. So what I really liked with this approach is that we're taking a potential of 8 gigabits per second, 1 gig on each of those 8 ports, and we're aggregating that into a 10 gig port. So this means that I will not oversubscribe that output port. Also, I'm working with a tap. By working with a tap, I ensure that my timing is accurate, my packet ordering is accurate, and that I'm not going to make a configuration change that's going to take down the network. And I've done this long enough that I've been in facilities where one of them, the guy went in, typed in the command, and I went back to the desk to sit down, and I heard the help desk going, hey, is Salt Lake City down? I thought, oh, Salt Lake City's that link we tapped, or we spanned. And I went back and asked him, I said, what'd you type in? He typed in the right command, but on this particular switch, every once in a while, when you spanned a port, it would reset the port and it took that link down. So by going in with a tap like this and putting this in ahead of time on links that we need to monitor on a regular basis, we are less likely to run into issues. We don't have to make any configuration changes to our switches. And depending on the environment that you're in, those configuration changes may require a change order. So I've got to go through the whole change order process. So if you look at a printed circuit board, in many cases, there's test points on that printed circuit board. Those test points are to facilitate the ability to go in and test that to make sure it's working right. This becomes a test point in our network. And if you're putting these in at the time that you build out your network, the cost is minuscule. In fact, what I've found is if this is something you plan for and it's in the big picture of things, it doesn't even show up as a decimal point no matter how far down the line you look. However, if you have to go back later and ask for it, then people go, well, why didn't you get that at first? Or why are we buying this? So I really, really, really want you to think about when you're building out your networks, when things are being built out and you haven't even run any production traffic across it yet, where would you plug in to monitor your network when things go wrong? Because they will. And you notice on a car, they don't weld the hood shut. So we always have ways to go in and troubleshoot things. By putting things like a tap like this in the path of the packets, we're more likely to get the right packets the first time, right? Because we're able to go in and see that information. Now, I wanted to go in and make sure that this booster did what the booster is supposed to do. So what I did was I set up a test where I ran 3 full line rate, full duplex, 1 gig traffic flows through 3 of those taps. So I had 6 gigabits per second flowing through there. Then I plugged a voice over IP phone into the other tap. And I went in with my Etherscope NXG and I did a packet capture looking for just the traffic for that phone. So out of that 6 gigabit per second plus 1 VoIP call stream of data that was going through, I only wanted the VoIP call. So how could I go in and make sure that I got the whole VoIP call? Well, what I did was I used the voice over IP analysis in Wireshark to take a look at the RTP stream for that voice stream. And what I got out of that was 0 packet loss. I lost 0 frames. So this tells me that my analyzer captured every one of the frames in that voice call because each one of those RTP frames has a sequence number on it. So in this case, I was able to validate that out of a 6 gig data stream, I was able to pick out that conversation I was interested in. Okay. The Profitap Iota. So the Iota is really a combination. We'll bring this up right here. We're not going to really dig into this one too much today, but here's another one from Profitap. This is the Wireshark. It's got a USB 3 connection on one side, and this particular one is a 1 gig. It's got a 1 gig inline tap, or we can use these with span. So this allows me to get in there and capture at full line rate gig, full duplex. Well, Profitap has drivers for Synology NAS so that we could take the data we captured with that, we could merge that or write that to the NAS. Well, what they did was they shrunk all that down to the Iota. So the Iota supports 10, 100, 1000, or 10 gig, if you get the 10 gig model, copper or fiber, and it captures directly to disk. So it's taking that data and writing it to disk. It's got 1 terabyte of internal storage. So what we're going to see is when we go in to capture those write packets, with the Etherscope NXG, we're going to be capturing a very specific conversation or a specific port number. With the Iota, this is the type of tool that when I go in to do an analysis job, I'm going to put this in line, I'm going to plug it into something like the booster, I'm going to let it run. Because something will break, something will happen, and somebody will come back and say, hey, we had a problem about 10 minutes ago. And typically that is when you're explaining the problem to me, the problem will happen. And so Murphy's Law of Packet Analysis also says that the second I stop the capture on the Etherscope, the problem's going to happen. So having an analyzer that's capturing all the time allows me to go in and make sure that even if I wasn't specifically looking at that time, I've got something out there capturing. So someone says, hey, what just happened? I can go in and answer that. Now, what we're going to see on the next slide is that the cool thing with the Iota is not only does it capture the packets, but it takes all that flow information for those packets and it puts it into a database, and then it creates visualizations of that database. So this allows us not only to capture the packets, get those packets out and analyze them, but also I can visualize what's going on as far as my conversations out there. One thing I really like on this, you can kind of see it in the background right there. There's a button that says stop, start, and stop. This has a hardware start and stop button. So I can take this, put it in a little tiny travel case that comes in, send it out to a customer, say, hey, put that in line with your PC, hit the start button. Capture, wait for the problem to happen, stop, send it back to me. I can go in and analyze that traffic. So this falls into the getting in the path of the packets. We have to capture when the problem occurs. So getting those right packets the first time is all about planning. It's not a mistake. We don't accidentally get the right packets. We get the right packets because we planned out how are we going to get out there and get in line and do that capture. So here's the dashboard. We're going to take a look at this in just a minute, but this is what I see with the Iota. So once I have that in line, I can now see that traffic going across the wire, and down here, I can see all my conversations. So I can see who's talking to whom. And this gives me an idea if I see that traffic jump way up. You know, I've I've got a home office I work out of, had the IOTA set up. I noticed the latency went up on my internet connection. So I asked my son, I said, so downloading anything? And he got the, one of the new Xbox games. I'm not a gamer, so I don't remember what the name was. But the download for it, 175 gig, showed up right there. We could see it. We could go out and dig into that traffic if we wanted to. And the neat thing here is that I can go in and drill in using this screen into any of these conversations. And right up here, we see it says get PCAP. I can go out and get that PCAP file, bring that down, away I go. All right, so the deployment process. What would we do? How do we put this all together now? Excuse me. We use the booster to tap key locations. So what I've done is I've put the booster in. I've got a picture of it here in just a second. I've got that booster tapped in outside my firewall. I've got it tapped in inside my firewall. I've got it between some of the links that go out to various wireless access points. So I'm capturing in 4 different locations and aggregating all that traffic together. One of the things that was on the slide that I didn't mention is that the booster can be configured to insert a VLAN tag based on which of the 4 taps we use. So later on, this allows me to go back and segregate that traffic based on VLAN tag. So if I say I just want to see the traffic going in and out of my internet connection, I could filter on that VLAN tag. So that's a pretty nice little feature there that I can go in and separate that traffic later. The next step is, if I'm going to go out and do an analysis using this equipment, that I'll connect up the IOTA. I'll get that IOTA in place. This could be on a uplink going out to a switch covering a group of users. This could be going to my servers. This could be going to an internet connection. But what I'm going to do is I'm going to put the IOTA in a location where I want to capture traffic for a long period of time and capture a lot of it, and then go back in and use the packet capture or filtering capabilities to drill in. Then I'm going to connect up my Etherscope NXG. I'm going to start discovery, because here's the thing. If we don't know the addresses for devices, if we don't know what their MAC address is, their IP address, it's going to make analyzing that traffic and making sure we got the right packets the first time much more difficult. Then I'm going to remote into the IOTA, and we're going to remote in using the Etherscope NXG and start capture. And then we're going to take a look at using the 10 gig packet capture capability here. Okay. So we're going to tap some links. We're going to capture some packets. We're going to upload those packets to Link Live. We're going to download that to the computer, analyze with Wireshark, and we're going to save our discovery. So here is our little setup back there in the back room. We've got our IOTA hooked up. Now this IOTA is tapped in line with my internet connection. And down here, we have our booster. So our booster is tapped into our internet connection as well. And it's tapped into a couple of uplinks I have to switches, and it's tapped into the link that's going to my studio here. And then what we're doing is we're coming out of that booster with some 10 gig optics into some OM2 fiber. Not something I'd recommend leaving laying around because it's orange and it's 50 micron and it'll create all kinds of problems. But if you know what it is, then it's okay. And then that fiber terminates right here. So we've got that plugged into my Etherscope. And so what we can do is we're taking the data that we're aggregating across all of those links, and we're bringing that in here and sending it out that port right there. So that's where I say questions, because now what we're going to do is we are going to stop sharing that for a second. Switch over here, and we are going to share the Etherscope NXG. So here's my Etherscope NXG. This is my Android-based handheld troubleshooting tool. And in fact, if we switch over, there's this device. So what we see is if I come over and tap on the screen right here and I go to auto test, brings up my auto test. Now, one of the things that we need to do with the Etherscope NXG is we need to run a quick little auto test just to link up. So I'm going to come in and hit start. And when I hit start, and now I can hit stop because I'm not going to get a DHCP address. I'm plugged into a tap. But in this case, what it does is it says, hey, you connected at 10 gig full duplex. I can even drill in. I can see my receive power. I can get a picture of what's going on in here. So once I have gone in and established that 10 gig connection to that tap in the back room, I can come back out to my home screen and I can go to my packet capture. So it says, hey, do you want to discard what you captured before? Yes, because I wanted to make sure all this was going to work before we started this webcast. So now I can come in here and here's my packet capture. So I can go to my filter and I could say, what do I want to filter on? I could set the size limit of my capture. I could set the slice size. And this goes into getting those right packets. Sometimes we don't need all the data, especially if we're looking at encrypted traffic. The data portion of the packet's not going to do us any good. So by slicing the packet, we can increase the number of packets that we can fit in the buffer and increase the amount of time that we're capturing, because we're not capturing data we're not going to end up using. I can select my capture port. Now this is where I can use the wired or wireless port. And this allows me to go in and do a Wi-Fi packet capture. And over the years, that has always been a challenge because I've had the right adapter, the right driver, all of that. Well, in this case, if I need to capture on the wireless side, I select the Wi-Fi port. Now I can select what channel I want to capture on, what BSS ID, what MAC address of a client I want to capture. I can set those and use that to do my wireless capture. Today, we're going to go with wired. I could set up my filter right here on my MAC address. I could set an IP address. So if I wanted to capture traffic going out to a specific IP address out on the internet, I could do that. In fact, we're going to do a big capture to start with, but then I can show you where if I set a filter on an IP address here, it's going to take all the traffic it's receiving from that booster. So the traffic on the outside of my firewall, the traffic on the inside of my firewall, and it's going to merge all that traffic together for me, maintaining packet order, and get that to me so that I can see what things look like. I could go by VLAN. We could scroll up. I could do port. Also, I can do a NOT. So sometimes we have something burning up all of our bandwidth, such as this webcast right here, right? So if I wanted to eliminate this webcast traffic, I could go in and set a NOT filter and say, hey, let's get rid of that. So for right now, we're just going to leave all of that default. I just want to go in and grab a quick capture of everything. So now I can come up here and hit start. And again, and doing it on the screen is somewhat deceptive in that I can come in, and this is a handheld tool. So all of those things I was doing right there, I can do just by tapping on this screen. So I don't have to figure out a place to set up my PC and things like that. I can come in and just come in here and start tapping on the buttons on that screen. Now, the other thing that's important to note is at the same time we're doing this capture, we'll let that capture keep running back there and come back out to the home screen. If I go to discovery, it's discovering what's going on with my network. Now, here's the cool thing. Right up here, we can see that that's scanning. It's going through and scanning all the channels. We are not connected to an AP. We're not connected to a specific device we're scanning, but look at this. If I come in here and I take a look at this OnePlus right here, it shows me there's the OnePlus. There's what channel it's on. There's the SSID it's connected to. Let's find one that's connected to an SSID that I've got right here. And now this shows me this device right here is connected. Its IP address is 10.0.0.211. It is on channel 11. It's using 802.11n. There's its IP address. There's the AP it's connected to. There's all that information. So we were able to collect that information without being connected to the wireless network. We're taking what we learned on the wired side, combining it with the wireless side. So this gives us a way I can come in and start seeing where things are connected. So for instance, if I go in and let's see, we've got a lot of wireless devices. Well, let's do this. We're going to throw a quick filter on here. So I can go to IP subnets, and I'm going to filter down. Oh, let's do this. Sorry. We're going to go to our discovery. I'm going to go to my extended networks. We're going to turn on IOTA's office. We're going to turn these on. So what I'm doing is I'm telling the Etherscope NXG not only to discover the local network, but to discover those other IP subnets as well. So in the case of IOTA that works with me, this is going through our VPN tunnel to her office and discovering her network. So now, if I come up to my filter, I can say, let's see. Let's go in. Let me just refresh my discovery real quick. So we'll go ahead and rerun that discovery. And it shows me up here at the top where I'm at in my discovery. But what I want to show you is I can use this with that extended discovery to figure out where IOTA's devices are connected. So when it comes into capturing and figuring out where we need to capture so that we get the right packets, being able to know where devices are connected is critical. So we're at 70% right there. Okay. Somebody brought up a point, and that is it really helps finding rogue devices. I was out at a school district and somebody had a wireless access point connected up so that they had their own little wireless network running. And we used this as a way to figure out, we went in there and said, hey, we need that access point. They wouldn't give it to us. So we just used this to go in and figure out where that was connected and shut that port down. So we're at 90%. What I'm going to do is I'm going to come in and put a filter. I'm going to filter on just the devices at IOTA's office. So now it shows me, hey, here's these devices at her office. So I'm interested in, let's say, this Raspberry Pi at her office right there. So what this does is because it used SNMP to go out and do that discovery, it said, hey, here's this device, and it is connected to, let's see, let me click on, make sure I click on the right device here. There we go. So I'll click on the backup network attached storage at her office. And in this case, it says, hey, here's the NetBIOS name, here's the IP address. Here is the port and switch to which it's connected. I didn't have to call and wake IOTA up and say, hey, where's that NAS connected? So now when I go into, even if I have to do a span, when I go in to do that data collection, I know where those devices are connected. So that discovery gives me the name, the MAC address, the IP address. It gives me where it's connected. So now we're going to go back to our capture. Now, what happened was I left the capture screen, and it will do the discovery in the background, but all the other things I did, I needed to stay on the discovery screen. So I can come in here, I'll click on the name. I'll say, I'll come over here to my little Bluetooth keyboard. I'll call it democap.pcap. And I could go in and I could hit save right here. And now what I can do is I can say, I want to save to downloads on here. I also want to upload that to Link Live. So one of the keys is I've captured the packets. How do I get those packets off of the capture tool and get that uploaded somewhere? So I'm going to go ahead and hit save. So now it's saving it to Link Live. So what it's doing is it's uploading that out there to Link Live, and I'm going to be able to pull that file down and see what was in there. Now let's come out here while we're on the Etherscope, and I want to show you how I can use this to access the IOTA. So what we're doing is, as far as combining tools to get those correct packets, we've combined the 10 gig 10 gig packet capture capabilities of the Etherscope NXG with the ability to tap 4 links on the booster back there. We've got the IOTA in place. So now I can come in, click on my web browser on the Etherscope, and I can connect to the IOTA. Now, coming in here and connecting into the IOTA, this is where I see my dashboard. I can see what I've collected. So if I'm using my Etherscope NXG to go out and get all this set up, what I can do is I can come in and select my capture. I can go to my interface configuration. Now, I am going to push tapping in line as hard as I can. Sometimes we can't break the connection. Sometimes we need to connect to a span port, or we need to connect the IOTA to the booster. So now we can tap 4 links with it. In that case, I can come in and change the configuration on the IOTA. Do I want it to be an inline device? Do I want it to be a span device? I can capture on both ports at the same time. So again, this is kind of that philosophy of having building blocks where I can build things. I don't have a device that is only inline. I have a device that has 2 span ports that allow me to capture on each of those ports at the same time. Then I can come into capture control and I can start my capture. So it shows me, how much have we written to disk so far. This has a 1 terabyte drive in there. I can set it up to automatically clean up those files so that it will delete the oldest files, put the newest files in, and collect that information. But again, once I get that going, I can come out here and see what my traffic looks like. So I can do all this with the web browser on the Etherscope. I haven't had to dig out my laptop yet. I can do all of this with these handheld tools I have. Okay. Now, what I want to show you, and we're going to stop sharing that for just a second, and let me bring up Wireshark. Then we'll bring up our web browser and we'll download a trace, and then I'm going to take a look at the questions. And I always want to be really careful with your time because, well, it's valuable. All right. So let's come over here. I'm going to share Wireshark here. So here's a capture I did. Now what I did was I took the discovery information that I collected from the Etherscope NXG, and I used that to create an ethers file and a host file for Wireshark. So now when I come in and take a look at Wireshark, notice how few IP addresses I see. Most everything is Mike's Etherscope NXG. We see printers. We see all, in fact, that's kind of interesting. We see all, oh, there's my Etherscope going out and talking to my printer. But here's an important one. Not only is this giving me my IP name resolution, but if we come down and we look at an Ethernet layer, we look at Ethernet, it's giving me the resolution for my MAC addresses as well. That's because I did my discovery. So it doesn't matter how well I do that packet capture. I need to make sure I get all the packets, but also I need to see what's going on out here as far as these packets going across the wire and what's happening. So if I came in and I started looking for some traffic, and I'd done a nice little filter and I forgot to save the filtered traffic. So let's do this. We're going to do a quick search. Yep. All right. So this is where those good old live demos, man, I sure thought I filtered that. All right. So here's what we're going to do. We are going to come over. We're going to log into Link Live. We're going to grab that and bring that over here. Okay, so here I've gone in and I've used Link Live to do discovery. And in fact, if I come down here, here's my office network. And well, actually, we're going to bring this up. Here are all of my, here's the discovery information. I've kind of, I don't want to spend too much time digging around on things. So what we're going to do is we are going to find my watch. There we go. It's at 211. So now that I've used my Etherscope to go in and do my packet capture using my booster, I could come up here and say ip.adder equal 10.0.0.211. All right, so it gives me a name. There's my Moto 360 watch. Here is what I think is so cool about being able to tap in multiple locations. I am tapped in outside. I am tapped in on both sides of my firewall. So in this case, if I came in and found a TCP SYN, so what we're going to do is I'm going to take this conversation right here and I'm going to say follow TCP stream. One of the questions that comes up all the time when I'm out troubleshooting, what's the latency of the firewall? I think the firewall is delaying things. So what we get out of this, oh man, let's see. Sorry. I came into this all prepared that I would just open this trace file and it would be exactly the way I wanted it. I did a save instead of an export. So we're going to do one more filter. All right. While we're doing that, aha, okay, here we go. Then I'm going to come back and I'm going to start talking about questions. Here is where my watch sends the TCP SYN out here to the Android Wear Cloud. So there's our SYN. Now, because this is going through a NAT box, and I'm tapped in on both sides of the NAT box with that booster, even with a tool like the Etherscope NXG that's designed to capture at full line rate 10 gig, but doesn't have the inline capabilities, by combining that with the booster, I've now tapped into both sides of that firewall. So what we see is we see the packet come in to the firewall. And how do I know that? Well, I can now come in because I did my discovery and it says the destination's my MikroTik router and the source is my Moto 360. We click on the next frame and it says the source is the outside of my router and the destination is my Comcast cable modem. But here is the really cool thing. If we look right in here, 170 microseconds. That is the delta time it took my router from the time it received that packet coming in to when it went out the other side. Now we could subtract out the packet transmission time and all that, but this gives us an idea of how much time our router's delaying it. This ensures that our router actually sent the packet out. We get the SYN ACK back on the outside 12.9 milliseconds later, and then it takes us 140 milliseconds to send that back through. So by being able to capture on both sides using a tool that has those 4 taps, and then combining that with a tool that has a very high degree of accuracy when it comes to capturing the packets and able to capture at 10 gig, now I'm able to see all this information that's going across. So, and then by combining that with my discovery information, so what I had done is, we'll come over here. Let's get that out of the way. Let me just show you what I did real quick as far as, if I come out to my discovery, I can go to my discovery. I can take that, I can say I want to upload that discovery to Link Live. So I'll give it a name. I'll say save to analysis files. So it's uploading that to Link Live. So now if I come back here to my analysis files, right there, there's Mike Office. If I click on that and I say view analysis, that's how fast it uploaded that. Here's all the information about the devices. So if I go to that backup NAS, it shows me where that device is connected and all that. So the next step was I came in and I clicked on my little action button right here. I went in and I said I want to save that to a CSV file. Now I have a comma separated values file that has all my names, my addresses. I took that, used that to carve that up, create the name file for Wireshark. When it comes to saving my packet capture, I come out here to uploaded files. We can come down. We've got a bunch of stuff that's been uploaded. Well, let's just do it. We're going to come out to our packet capture. We can stop that. I can say, well, we did that before. We uploaded that. So I just need to see where I put it. Yeah, we'll just say save. Oh, there it is right there. I was looking straight at it. There's my demo cap. There's my PCAPs. So I can come into that cap file. I can click on that. It's going to download that to my PC. We'll give it a second to stop flashing. I'll click on that. Now I've opened, now I can open that trace file and bring that up in Wireshark. There we go. There's that demo cap, and it gives us all the names of the devices that go with it. All right, a lot of information to cover. One of the things that the big points out of this is we need, if we want to capture the right packets the first time, we have to be in the path of the packets. And if we want to be in the path of the packets, we have to know where those devices are connected and where to tap in. So having the discovery capabilities, the Etherscope NXG to figure out how our network's wired up, having the ability to go in and get that booster in line to capture those packets. And then, as one last one here, and then I'm going to read through the questions. Let me bring the Iota up here on my browser screen, just because I want to show you a couple of really neat things we can do with that. I can tell you right there's where our webcast started, right? So you can see that constant bandwidth out of there. Not only do I have this dashboard, but I can come in here and I can create my own dashboards. And then we could access those dashboards either through the Etherscope or we could do it through here. But if I come in and click on attacks, this is one that I created where we go in and it shows us where the packets are coming from using the GeoIP features. So I'm going to add a filter. I'm going to say IP dest equals my router. Okay. And I'm going to say L4, layer 4, destination port is 23. What's 23? That's Telnet. And we're going to say TCP SYN equals 1. So now what I've done is I've just created a filter to say, show me those conversations where somebody is sending me a TCP SYN on port 23. Now it's going back and taking that GeoIP information and it is mapping that out. So now I could start seeing where that traffic is coming from. So we could come in here, we could start drilling in and using that GeoIP information to see who is trying to telnet into my network here. That's pretty cool. And if I want to go in, I can change things, like I could say, you know what, instead of 23, I want 3389, which is RDP. So who's out there trying to RDP into my network? So these are some of the things that we can do with that IOTA. So it's capturing in the background, collecting all this information. This shows me for the last 3 hours. I could come back and I could say, show me for the last 12 hours, what that looks like. Where are most of the RDP attacks coming from? So it just starts giving me an idea. Let's see. There's attempts to VPN into my network, all kinds of fun stuff. All right. So let me come over here. I'm going to stop sharing this for a second. And all right. So one of the questions that came in, will it do any layer 1 tests? Cross, split pairs, length measurement, like the old Fluke NetScout link runner did? Yes, it will. In fact, on the Etherscope NXG, if we switch over here, our port right here is not only our management port, but it's our wire mapper port. It works with the same wire view mappers that the link runner G2, the link runner AT2000 works with. It'll identify the number. It'll show us split pairs. It'll show opens. It'll show length. It'll do all that. So I can bring up, but we've got a nice little cable test in there. Works fantastic for doing that. Okay. One of the questions is about the write endurance on the IOTA storage. And I have not gone in and done any testing on that. I know that there are some folks with ProfitTap on the line. If there's any comments about that, I'm sure that they would be happy to comment back. If not, if you want to send me an email, I can get you an answer to that. I can make sure it gets to the right people there. So what we find is that this combination of tools that we've put together allows us to discover the network, figure out how things are connected. It allows us to go in, capture all the packets, and that is so important. I can't tell you, just the ability to capture 100% of the packets becomes critical. Over the years with laptops, all you have to do is miss a couple packets and it's going to make it really hard to get to the root of the problem. So if you don't know where devices are connected, if you don't know where that data is flowing, it can make it really hard to capture the packets. In fact, my dad was a management trainer most of his career. He had me listen to a tape that I thought was interesting. It was a cassette tape back in the day. But the person that was talking about helping people be successful said that oftentimes it's hard for us to come up with, exactly what you need to do to be successful. So what he did was he would oftentimes think about, what could we do to make somebody fail? And then we flip every one of those around. So if I wanted you to fail at capturing the right packets the first time, I wouldn't let you know where devices were connected or where those traffic flows were. I wouldn't let you know what name was assigned with which IP address and which MAC address. I wouldn't give you a piece of equipment that would allow you to capture 100% of the packets. I wouldn't give you something that would allow you to visualize what the data flows are going across there, so that as you're looking at this, you can go, why is that talking to that? By being able to have professional tools, we can get professional results as far as capturing the right packets and being able to analyze that. I get on my YouTube videos on Wireshark, right now I'm at 68,000 minutes of view time of people watching videos on how to go in and analyze packets. That is fantastic. I love that. But one of the biggest frustrations that they're going to run into is not getting the right packets the first time. So if you go in, you buy the tools that allow you to reliably capture those packets every time, it's going to increase the likelihood that you have the proper packets in the buffer. And when you go in to start analyzing those, you can get to the root of what's going on right there. All right. Well, my intent was to make this a lot shorter than it was. So I really appreciate everybody that's stuck on with this. I hope that this information has been useful for you. I hope that it's given you some insight into some things that we can do in there. You have my email address. If you have any questions, please don't hesitate to let me know. I've been recording this session, and I'm going to record the one I'm going to do in about 4 hours. I'm doing one more for the US time zone. So I will send out a follow-up email out to everyone with a link to that recorded version. So if you want to go back and take a look at this again, or you want to share it with your friends and family, coworkers, feel free to do so. All right. Well, thank you very much. And I hope that, Tim brought up that that will be posted out to Network Datapedia as well. So we'll get that up there. And I want to thank you for joining me. And I hope to see you in another session.